Howdy, howdy, this is Mr. Potter. In today's video, we're going to talk about how to write functions, which are very similar to the methods that we wrote in C++. It's important to note that C++ is a functional language, so it's really dependent on the functions that we write in order to complete the processes. There are some little twists that are a little bit different from the way that we wrote functions in Java, and I want to kind of talk about those points. The other thing I want to address is how to output to a file, which we'll be doing both of those in today's video. So we're going to go ahead and create a new file, and I'm going to call this, call it functions.cpp. So we're going to have functions.cpp as our file name. I'm going to go ahead and make sure I include the proper things. So include IOStream. I'm going to be doing string again like we did last time. And I'm going to be including ofstream because we're going to be doing output to a file. Using namespace std, just like our usual thing. And I'm going to look at my int main. So what I'm going to be doing is, when I first learned C++, I learned it from a wonderful book called A Computer Science Tapestry by Owen Astrachan. And one of the ways that he starts teaching functions is by using nursery rhymes, because nursery rhymes have parts that are repeated and parts that change. They work very well for understanding functions and parameters. And so I want to continue with that ilk. So what I want to do is I want to sing The Wheels on the Bus. Now, if you've ever heard that song, that's the one where it goes, the wheels on the bus go round and so forth. So what I want to do is I want to output that to the screen. So I want to write a method called wheels. So I'm going to say void wheels. And all I want it to do is I want to print out the song. So I'm going to do cout, and I'm going to say the wheels on the bus go round, and an inline, and round, comma, round, and an inline. And then cout, the wheels on the bus go round and round, inline, and then cout all through the town. And we'll do two inlines here because it's the end of one stanza. And if this were Java, I should be able to go into my main and just call on this void function, wheels. And that should be sufficient because wheels is a void method. And so it's just going to execute the statements in that void method. I don't have any parameters to worry about, so it should just cout this. So I will go ahead and save that. I'm going to do my G++. So let's go ahead and create a new terminal. So G++, and it's going to be functions.cpp with an output of functions.exe. And it's telling me that there's an error. It says it has no idea what wheels is. And C++ is different from Java in that the code is compiled top down. So it says, okay, there's an include statement, there's an include statement, there's an include statement, there's using namespace main, there's int main. Wait, wheels? I haven't seen any declaration of wheels in the first 11 lines of this code. And so C++ is confused and it throws an error. It doesn't realize that if it just looked a little bit farther, it would see wheels down here. And so what I have to do is I have to kind of do a little foreshadowing here. Something to let C++ knows, hey, there's a function called wheels. You're going to get to it. It's going to be great. And the way I do that is through a method called prototyping. So with prototyping, I'm telling C++, hey, there's going to be a method called wheels. It's going to be of type void, and there aren't any parameters. So don't worry about it. So we're going to see void wheels and semicolon. So what I've done here is I've basically said there's a method, there's a function called wheels that's going to show up later on. So if I save this and try and recompile it, it has no problem. And when I do functions.exe, I see the wheels on. So there's my first stanza of Wheels on the Bus. Very exciting. What's nice about rhymes is that there's a certain part that repeats, but there's also certain parts that change, and it helps children to understand patterns and recognizing those patterns, as well as being able to create new verses on their own. And one of the great things about being a kid is being able to create your own version of the Wheels on the Bus. You can come up with probably 1,000 different versions because there's all sorts of things that happen on the bus. So what I want to do is I want to prepare for that and realize that there are certain things that do change. For example, I deal with the wheels on the bus. Maybe it's some other part on the bus that changes. And there's also this action. What is that object doing? Well, they're going round and round, and this is something that's repeated a few times. So what I want to do is I want to create a new method, or new function called void wheels2. And there's two things that I want to do in here. One is I want to specify the object. Now, these are type string because they're characters put together. So I'm going to say string object. And the second thing is some action. And I know from Java that if I have this type of method header, then I can expect to access these two variables, object and action. These parameters are going to be accessible in my program. So what I've got going to do here is I'm going to say cout the, and then I want to output the object on the bus go, and then I want to direct the action and inline, and then I want to cout, and I'm going to do the action, and then a comma space, and then the action, and an inline, and then I want to cout the, and then my object on the bus go, and then action, inline, and then I want to cout all through the town, and inline twice. Now, in order for C++ to not have a problem with this, what I need to do is I need to make a prototype for wheels2. So up here in my prototype, I'm going to do another void wheels2 semicolon. And of course, white space really doesn't matter. But now I want to do a couple of method calls here. So I want to say wheels2, and I want to say the wipers on the bus go swish, swish, swish. And then I want to do wheels2 with the brakes on the bus go squeak, squeak, squeak. And so what I've done is I've got two function calls to wheels2. One where I'm replacing object with actual parameter with the formal parameter of wipers, replacing the actual parameter action with the formal parameter squish, squish, squish. And then the second time I'm replacing object with brakes, and I'm replacing action with squeak, squeak, squeak. So let me save this and recompile. Okay, couple of issues here. So it has a problem with wheels2 because my prototype should have two parameters. My prototype needs to match my errors. Notice it's telling me, hey, there's too many parameters, too many arguments to this function, because it's expecting to be no parameters, and I'm giving it two parameters. And it says it's declared here on this line 11 space 6, and the issue is on line 17 space 45. So I need to make sure that my prototype reflects that, and even notice that my screen tells me, hey, you should have a string object and a string action. So it's kind of giving me a hint of what I'm doing wrong. So I'm going to recompile, and we're going to run it. And so notice that we've got the wheels on the bus go round and round, the wipers on the bus go swish, 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 the brakes on the bus go squeak, 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 all through the town. So I can do as many versions as I want, and each one's going to be changed by the action that's here, as well as the object and the action that it takes. So I've got this idea that I can create void functions, just like I could create void methods in Java. The main difference is that I have to have these prototypes up ahead to kind of give the computer fair warning, hey, there's going to be a function with this parameter heading. So I need to make sure that the program knows this is going to exist, and then later on I can say, oh, by the way, here is that function I mentioned up above. But I did mention that we were going to be doing an output here. And keep in mind, as long as I am using cout, I'm kind of limited to outputting to the console. What I really want to do is I really want to take this and build a string and then return that string so that my main can actually output either to cout or to a file, whichever is the appropriate action. So I'm going to create another method, but this is going to be a return type method. I want to return a string. So I'm going to call the string wheels3, and I need the two parameters, string object and string action. And what I'm going to do is I'm going to create a string and build a string. So I'm going to say string result gets, and I want to build this. So it's going to be the plus object plus on the bus go, and then I want to do action. And notice that what I'm doing is I'm doing string concatenation, exactly the same that I did in Java. I'm just adding strings together to make a larger string. What's different is because I'm not directing output to a stream, I'm not going to be using ENDL. Instead, I'm just going to be using the old traditional \n that we've used before. And then I can say that result gets result plus, and now I can do the second line, say action plus a comma space plus action and \n. And I could even say result plus gets. I can even use the plus equals operator to concatenate. It's going to figure out the result of everything to the right of the plus equals and then concatenate. So I can say the plus object plus on the bus go plus action. And want to make sure that that is in quotes correctly. And terminate with a semicolon. And then result plus gets all through the town. And then I'm going to put two \n/ns. And then I've got this result that I've built up. I built this string together. And now what I want to do is I want to return result. So this is going to return whatever the string is that I've built back to whatever function called this. So I need to make sure I've got this as a prototype. So I'm going to go ahead and just copy this line of code and put it up here in my prototypes. Remember, prototypes must end with a semicolon. I'm letting it know that, hey, there's a method down below that's called this. And if this looks familiar, this should look very familiar when we were talking about interfaces or when we were talking about abstract classes. We were saying that this method has to be written some point in the future. We just happen to be writing it later on in the file. But we have to do this because C++ reads from top down, compiles from top down, and if it finds a function that it doesn't know the meaning of, it's going to throw a hiccup into things. So now what I want to do is I want to go ahead and try to cout my result. So I'm going to say wheels3, and I'm going to send it a driver that says, please sit down. Now, right now I'm using console output, but in just a few minutes we're going to talk about how to do this through a file. So I'm going to go ahead and save this. I'm going to compile and pray for no errors, just one error here. Wheels3 was not declared in the scope because it's wheel3, not wheels3. Did I mess that up? It should be wheels3. Okay, so I just need to make sure I have all of these identifiers agreeing. So now if I run this, then I'm going to see the driver on the bus goes, please sit down. Action. Oops, did I put action in quotations? Eek. That should just be a plain old action plus a comma. Okay. So let's try recompiling this and rerunning it. And so now you see the driver on the bus goes, please sit down, please sit down, please sit down. The driver on the bus goes, please sit down, all through the town. So because this is returning a string, I can take the output of this method, output of this function, and put it anywhere I would expect a string. Now, we're using the insertion operator to put it into a console output, but I certainly could go ahead and create a file, and that's what I'm going to do now. So I'm going to take this line and just insert a couple of spaces here, and I want to create a file object. Now remember that to do an input file stream object, it was ifstream. So if I want to do an output file stream object, it's going to be ofstream. And I'm going to go ahead and call this output. So I've created an output stream and I need to open a file. Notice that I don't have a file over here called output.txt. I'm going to create it. So I'm going to say output.open and I'm going to put my file name here. So I'm going to say output.txt. And then now instead of cout, instead of outputting towards the console, I'm going to output towards my output file stream called output. And then one thing I definitely need to remember, especially when I'm doing output, is I need to close the file. Otherwise, I'm going to lose the contents of the file. It's basically going to empty like a bucket with a hole in it. So I'm going to do output.close with no parameter. So now if I save and compile and run, notice that output.txt got formed out here. And if I double click, it's going to show me that same, the driver on the bus goes, please sit down, all through the town. The same output that we had before, but because it's a string, I can direct it not just to my console output, but to my file output. Whereas with the other two methods that we wrote, because I'm using void methods and because I've locked in cout in this function, I'm run into that problem of I can only direct this towards output. So what I could do is I could take these wheels 2 and change them into wheel 3 function calls here. So I could insert those here and change the wheels 2 functions to wheels 3 functions. And that way I could have more of the song being placed into my data file. So two things that we talked about today. Number one is we talked about functions. We talked about how I need to prototype functions. That way the computer knows to expect a function with this name and this parameter heading. And we talked about how to write a function. Writing the function is exactly the same as it was in C#, exactly the same as it was in Java. The only thing that's different is that I don't have to specify public or private. I don't have to specify static. In this case, it's just doing it. I can have void functions which just perform a task. Notice that my void functions have no return statement. Although there's nothing wrong with having a return statement as long as it's just a plain return with no object that I'm returning. So void methods perform a task. They're not actually going to return a value. They're just performing a task. Whereas string, and I certainly could do this as an int or a char or any other type returning method, is actually going to return an object of that type when it's completed. It's either going to return an int or a char, or in this case, it's going to return the compilation of the string that we've created. The benefit of using a return type function over a void type function is that using this return type function actually gives us a little bit more control of what we can do with that result. So here I can actually direct that result towards an output file, which is the second thing we talked about here. We basically use the exact same commands for our input file stream as we did for our output file stream. The main difference, of course, is the difference between output and input. Output uses these insertion operators, whereas input, which we're reading from a file, which we did in our last video, uses the extraction operators. In other words, it was putting stuff, so input would do extraction operator into a variable. So that's the main difference between input and output. That's really the only difference. Everything else so far is exactly the same. One of the things that we'll talk about later in this course, much later, is we'll talk about how to append output to a file rather than just starting new. We'll be able to take an existing file and add stuff to it. And we'll also talk about how to go backwards and forwards into a file, maybe inserting data into a file. but that's a video for another day. So once again, this is Mr. Potter. Thank you for watching. Have a great day.